Understanding beta oxidation of palmitic acid in a very short way. You see why beta oxidation of fatty acids is important. Fatty acids are rich sources of energy, but this energy is released only when the fatty acids undergo beta oxidation. So the main importance of beta oxidation of fatty acids is the provision of energy. Now, fatty acids are present in cytosol, but they are activated and transported to the mitochondrial matrix where their beta oxidation takes place, which is why beta oxidation involves 3 stages. Activation of fatty acids into fatty acyl coenzyme A, transport of fatty acyl coenzyme A into the mitochondrial matrix, and finally the beta oxidation reaction. Let us understand the activation. Fatty acid combines with coenzyme A synthetase, which gives fatty acyl coenzyme A, the activated form of fatty acid. Enzyme responsible is acyl coenzyme A synthetase. Transport, let us understand that. Fatty acids are now activated to the fatty acyl coenzyme A form, but still can't be transported to the mitochondrial matrix. So, they need a specialized carrier molecule called carnitin. Carnitin transports fatty acyl coenzyme A across the mitochondrial membrane. This process is called carnitin shuttle. But short chain fatty acids don't need carnitin or carrier molecule. So even after the activation of fatty acids into fatty acyl coenzyme A, only the long chain fatty acids need this carrier molecule carnitin to be transported to the mitochondrial matrix. I have drawn a very simple representation of carnitin shuttle. This is mitochondrial membrane. This is in cytosol in mitochondrial matrix. This much do you understand. Now, what's happening in the cytosol? Fatty and okay, remember we're talking about the transport, okay? In cytosol, fatty acyl coenzyme A combines with carnitin. Yes, the carrier molecule. It combines with the carnitin and gives fatty acyl carnitin along with coenzyme A. And the enzyme responsible is carnitin acyl transferase 1. Fatty acyl carnitin is the combined form of fatty acyl coenzyme A and the carnitin. So, along with this carnitin, the carrier molecule fatty acid can now finally be transported to the mitochondrial matrix, where the kahani doesn't end. You see, fatty acyl carnitin combines with coenzyme A. Fatty acyl carnitin combines with coenzyme A, and it gives our needed product, fatty acyl coenzyme A. What happened just now? Fatty acyl coenzyme A combined with carnitin, and it carnitin act like a vehicle, and it dropped fatty acid in the mitochondrial matrix. So the fatty acyl coenzyme A is now ready in the mitochondrial matrix for the beta oxidation. This is what we actually needed. And fatty acyl carnitin combining with coenzyme A also gives carnitin, which again goes back to the cytosol, and the cycle repeats. In the mitochondrial matrix, the enzyme responsible is carnitin acyl transferase 2. Okay, this was very easy, right? Let us understand the third stage, beta oxidation reaction. You are smart enough to understand this flowchart that I have just written. So I'm only telling you the mnemonic, which is kind of inspired from a Bollywood song, Pehla Nasha. Udta hai phiru in hawaon mein kahi. I may sing bad, but this is important. So listen very carefully. Fatty उड़ता ही करके फिरा. Fatty उड़ता ही करके फिरा. Okay, bye.